I want to do some calculations here related to the law of sines, just to show you how these things work. I got a triangle here. I know angles A and B. I don't know C. I do know side A. I don't know side B, and I don't know side C. If you think back to your geometry days, we had congruence theorems. That is, here's two triangles. Are they the same triangle? Are they congruent to each other? And there were things that you looked for. Angle, side, all that kind of stuff. This information that I have is two angles and a side, which is not the side in between the two angles. So this is what's called angle, angle, side. There was a congruence theorem related to angle, angle, side. So there is a unique triangle here. And it's not too hard to find. I can calculate side C, angle C here pretty quickly because all the angles have to add up to 180. So angle C is going to be 180 degrees minus 70 degrees minus 65 degrees. So that would be 110 minus 65, 100 minus 55. That'd be 45 degrees. Okay. So in some ways, angle, angle, side is very much the same as what I would call angle, side, angle because I never use the 8 here. So whether I had these two angles or those two angles, I've got all three angles. Okay. So this calculation didn't really use the side. Now I'm going to use the side to find these other two sides. Let's go for side C here. Law of sines says that side C divided by the sine of that calculated angle 45 is equal to, now I'm going to use something that I know, 8 divided by the sine of 65. That is, I need to have both an angle known and its opposite side to get this whole fraction completely known. Then I can use the angle to find the side, or maybe in the future I'm going to use the side to find the angle. But let's do it this way first. Once I've got that, I can multiply both sides by that denominator and get that C equals 8 times the sine of 45 degrees divided by the sine of 65 degrees. So I pull out my trusty calculator here. I don't know if you can see it. Maybe you can. Let's do a quick check of the mode. I'm in degree mode. Good. So I'm going to do the calculation 8 sine 45 divided by the sine of 65. And I get 6.24 and some change. All right. So there's that. Now I'm going to go back and find B. Well, one thing to be careful of, this is not a right triangle, so I can't use Pythagoras here. So I gotta go still use the law of sines here. So how about B divided by the sine of B? Oh, but the sine, well, I know what B is. This is 70 degrees equals the known information here, 8 divided by the sine of 65 degrees. I'm inclined to use the same given knowledge here rather than the calculated ones if I can avoid it. Okay. Because if I made a mistake with that one, then I'd be guaranteed to make a mistake here if I used the C and the 45. I'm going to use the 8 and the 65. That was given to me. Okay. So here we go. Solve for B by multiplying both sides by that denominator. And I've got 8 times the sine of 70 degrees. Whoops, 70 degrees divided by the sine of 65 degrees. And again, I'll pull out my handy-dandy calculator. And 8 times the sine of 70 divided by the sine of 65, and it tells me 8.29-ish. All right. When you're doing these calculations, I would say, give me a couple, maybe 3 decimal places at the end. Whatever you do, don't round in the middle. Don't figure out the sine of 65 degrees and give me 2 decimal places here and then divide by that with only 2 decimal places. Use all of the decimal places your calculator will handle until you get to the very last number. Okay. I have a reality check I do here. Because in any triangle, the smallest angle should be across from the smallest side, and the biggest angle should be across from the biggest side, and hence the middle angle should be across from the middle side. So with 65 being in between 70 and 45, I'm hoping that these two calculated things over here are one bigger than 8 and one less than 8. Sure enough, B was calculated at 8.29, and 70 is bigger than 65, so that's good. And the 6.25 is calculated here. That's the smallest side, and that's the smallest angle. Okay, that's not a guarantee that I got it right, but at least it gives me indication if it came out otherwise. I mean, if I'd calculated side C here as being 10, then something's wrong, because it's got to be smaller than 8, right? So anyway, there's one example. Let's do one more. Grab another piece of paper here and get that out of the way. Go. And let's say, it's actually interesting. The law of sines doesn't do everything for us. For instance, if you had a triangle look like this, how about 6, 7, 8? If I gave you all three sides, side, 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 there's certainly a congruence theorem for that. But when I try to do the law of sines, I have 7 over the sine of A equals 6 over the sine of C equals 8 over the sine of B. I don't know any of the angles, so there isn't any combination here of fractions. This one, that one, this one, that one, this one, that one. There's always two things unknown, and I don't know how to solve it, right? I need something else. And what I'm going to use is the law of cosines. All right, that's coming up in subsequent videos. Another one where we have enough information to determine the triangle is if I give you this angle here, A, as let's say 37 degrees, and I give you this side length here is 4, and I give you this side length here is 10. All that's fixed in place. There's only one side that's going to go from here to there. There's only one. This is side angle side. Again, that's good information. It determines a unique triangle. I ought to be able to find the lengths. However, again, I don't have a pair of an angle and opposite side known. Here I know the angle but not the side. Here I know the side but not the angle. Here I know the side but not the angle. And so the law of sines won't work. We need the law of cosines, and we will talk about that in a subsequent video. So, all right, well, that didn't do me any good. Let's try one more situation where it does work. Here we go. If I can grab this piece of paper. The iPad is charging, which is why I'm not using it right now. It's dead as a doornail. Here we go. How about if I give you this information? How about if I give you an angle here of 5, let's not just do 5, how about 52 degrees? This is 7, this is 9. That's the information. So what I have here is either angle side side or side side angle, depending on how you want to do it. It turns out there is not a congruence theorem for a side side angle, and the next video that we do, we're going to look at the side side angle in more detail. This one, it turns out there is a unique triangle. Sometimes you get two possibilities in this case. This one, it turns out there's only one, and here's how I would calculate it. Label some things here, A, B, C. This side is B. So I know two sides and the angle that's not in between. So two sides and an angle that's not in between. What I have, though, is I do have an angle and the opposite side. So that's good. I know that I have 9, and I can divide by the sine of 52 degrees. That's going to be equal to, what else can I do here? I've got this side, so maybe I can find that angle 7 over the sine of C. Now normally, I'd be thinking ahead a little more than I just did. Because the law of sines can be written either right side up or upside down, I'd be inclined actually to write this way. Since I'm trying to find the angle, let's put the angles on the top. The algebra is just a little easier, because now I'm going to solve for the sine of c. I've got the sine of c is equal to 7 times the sine of 52 degrees divided by 9. And I can use an inverse sine now. Sine c is the sine inverse of this thing, whatever that is. Sine 52 degrees over 9. Again, I'm going to let my calculator do the whole thing for me. I'm going to say, turn it on, I'm going to say sine inverse of 7 sine 52, that's a 7, 52 divided by 9, and I end up with 37.8 essentially degrees. Right. Once I know that, then angle B is easy enough to do, because B is going to be 180 minus 52 minus 37.8. And I get 90.2. Oh, almost a right triangle. As I say, there's peril. There is dire peril when you're using the law of sines to calculate an angle using the inverse sine, and we will talk about that in the next video. In this case, I happen to know, because the opposite side here, 9, was bigger than 7, there's only one answer. We'll talk about that in much more detail in the next video.